Okay, welcome to my talk on the basic unit test. I will preface this is kind of a high-level discussion of what unit tests are. I will get into some code. This is not an end-all, be-all of everything about unit tests. This is the fact that I've had several discussions with folks in the last couple weeks trying to describe what a unit test is or why we need a unit test and things along those lines. Okay. So, a little bit about me. This talk has evolved from having coffee chats with hundreds of hashtag 100dev members, folks on Twitter. It's a boot camp that started up back in February, it's still running. I've had a lot of conversations recently about what a unit test is and why you need a unit test and how to write a unit test and, front-end unit test versus back-end unit test and what is a unit test versus an integration test versus an end-to-end test versus working for QA and doing something along those lines. Okay. I can talk about unit tests because I've been writing code for 40 plus years. The last 12 years or so has been fully front-end, and the last 6 I've been heavily involved in writing unit tests for projects that I'm working on. I mean, literally thousands of unit tests. I've seen projects where massive amounts of code, 180,000 lines of code with 97, 98% code coverage was able to go into production and have very, very few issues over long periods of time. So I see the value of those unit tests. I've seen bad unit tests written. I've had cases where I've come into a project to find out that all of the tests were showing false positive. Okay. I do have a talk, and if you've seen my YouTube channel, it's on there, on what not to do when writing unit tests. And if you haven't written any unit tests, some of that might be a bit over your head, but there are code examples there as well. Okay. So, moving forward. My history of unit tests. I did talk a little bit about that recently. In college, I learned nothing about unit tests. I went to the University of Dayton, graduated around 1990. I don't even remember it being a conversation at that time. My career, my first job, writing code. I was told, literally, here's the quote, unit tests take too much time. We have to get into production now. Okay. During that time on that job, I explored writing unit tests. I remember writing a specific number of 3 unit tests over a 6-year window. I knew the value of unit tests because we had weird bugs that were cropping up all over the code. Next job. It's the current job I'm at, working at Leading Edge, where I work at various clients. And I talked about the scripting language, 97% code in depth. I write unit tests on projects. This isn't a choice in how I write code. This isn't a choice in how I prefer to write code. Unit tests have value in that they stabilize your code. They allow you to get a second look through your code. One of the issues that I've seen over time is folks have a hard time seeing their own code. You write the code and you're looking for that bug and you're looking for that bug and it's some misspelling. What I usually point out is if we had written unit tests as you tested that particular function where the variable was named wrong or whatever, you're going to get wrong outputs. Your tests that should pass will fail, and you'll take a second, much closer look at the code. Okay? So, I can talk about unit tests. I read a lot of them. What are unit tests? Unit tests are small tests that check the behavior of components in an application. We determine if a function is behaving correctly. Okay? When I first started looking into unit tests, when I first thought about using them with that first company, I saw unit tests as boring, as one more thing to learn. Okay, now I know that they're critical for any size application. That doesn't mean they're not boring. Okay, unit tests add time to development, but they also add a level of stability to that environment. Okay. So, what are unit tests? Let's talk about the types of tests. Okay. One of the things I want to point out, and I've heard this a couple of times, and actually I think it's a pretty good one. Don't get hung up. Is it a unit test? Is it an integration test? Is it an end-to-end test? Is it something that QA should handle? Don't get hung up on the type. We write tests to assert cases where our user would use our code. Okay? You're writing a unit test to come into that code the way a user's application would. Okay? We want to write tests that are deterministic. This is where we can determine the value cleanly. One of the ones I talk about in my talk on what not to do when writing unit tests is we talk about using like the date function in JavaScript. And so if we calculate something based off the current date within your test, now when you write your unit test, you got to go through all kinds of hoops because everything's based on the current date. So if you say, hey, I want something to show the last 10 days, the last 90 days, how do I show the last 90 days when the unit test could be run today, could be run tomorrow, could be run 90 days from now? I can't put a date in for that 90-day window correctly, cleanly. Okay? So we need to rework our functions a little bit, but again, don't get hung up on the type of test. And tests need to be unequivocally labeled. I have folks that talk about, oh, this has to be marked as a unit, this has to be marked as... Why? What difference does it make? You're testing a level of functionality. They do need to be labeled correctly. You want a good description on your unit test so that you can find it again, so that it also explains what you're trying to do with that test. Okay? The primary goal of testing is to catch errors before they ship, before they get into production. We write tests to cover common use cases. We want it to be able to fail quickly. We want it to fail quickly so that we can see where we made a modification to our code and it caused a different behavior. Okay? So, I don't know if it's a quick summary, but a summary of unit tests and what they are. Okay? So, advantages and disadvantages. Taking a quick look at this list here. Improve code quality. Clearly. Identify issues in early stage. Good. Process becomes agile. You can shift gears quickly. Simplifies debugging. Again, that look through, right? Many functions and tests can be copied between projects. Sorry about the slide deck, projects. I don't know where that came from. Between one project and another. Documentation of the system becomes easy. Okay, because your unit tests are a level of documentation of what's going on in the system. Okay? Disadvantages. They take time. Okay? There's a learning curve that can be a bit complicated with unit tests. And unit tests aren't perfect. They don't catch everything. Okay? If you write your tests so that you have a false positive, guess what? You're not testing anything. You're running a test, but you're not testing anything. Okay? And then there's the cost to fix bugs. So when we talk about the fact that they take time, okay, I want to point out here that there is an article that talks about the cost of fixing bugs. I'll have the link on the YouTube channel here somewhere through getUsers Guide to the Cost of Fixing Bugs. I don't know how to pronounce that. GITENTIAL.com. And they talk about how in design time, catching a defect, it's a 1-to-1. Okay? We're writing a unit test. You see a defect, you fix it right then so that your unit test works. Okay? As we implement, as you're running your code and you're looking at things as that code runs and you see something that's not working quite right, it takes 6.5 times more effort to fix a bug at that point. Testing, you've pushed code up to a dev branch or to a test branch, and you're testing it manually. Somebody else might be testing it manually, might be going to testing. Somebody might be running automated tests over there. There's 15 times more effort. I mean, number one, you got to push it up there. And you got to move it over to the other branch. And there's a manual testing all over the place to potentially catch a bug. Okay? And the worst case scenario, is finding a bug that needs to be fixed once it reaches production, because it takes 100 times that initial effort to catch a bug. Okay, and with those kind of numbers, we want to catch them as early as possible, because while people say that the disadvantage of unit tests is they take time, yes, they take time, but they take time initially. And that initial investment in time can be a lifesaver down the road. Okay, it has been for me. Okay. So the importance of unit tests. Okay, testing code with unit tests is critical for software development. We develop a function for a purpose. We're human. We make mistakes. Okay. It is clearly, easily possible to implement a function with errors or simply with unintended behavior. Unit tests take time. They save time. From experience, I can tell you, they save time. Okay. Important concepts. So here, I just want to kind of gloss over these. Don't want to really dive deep in. Okay. In most cases, you have a runner and a test library. You have something that runs the tests, and then the actual library that has the test features and things like that you're running. Okay. On the front end, in React, I'm going to go through the two major ones. React utilizes Jest for its test library. You can go to the documentation for React or for Jest, see what runners are being used and that kind of stuff. And you can use different runners. There are different choices and things you can do there. And then in Angular, the primary test library is Jasmine. Now, Jest and Jasmine aren't radically different. Okay, some of the pieces that we're going to see here later on apply across either one. We're going to use Jasmine for my examples just because it's the one I'm most familiar with. Okay. When you run your tests, there are two ways to run your tests. You run your test in a browser, or you run it in what's called headless mode. So Chrome headless. Okay, the advantage of headless mode is it spins up a browser, essentially, but that browser isn't shown to you. It doesn't open in Chrome. It opens in the background, and this allows our runner to run it from the command line, and you see the results on the command line. Nice part of that is when you're doing CI/CD and it's pushed up to some server and you're running something out there, that headless mode is really nice because it actually isn't spinning up a whole browser. Okay. We're going to talk about a little bit about coverage here. The two big ones on test coverage are how many lines are covered, how many branches are covered. Okay. Code coverage has 4 basic areas. These are the 2 big ones. And how many times do you touch a line? How many times do you touch a branch through a function? When you're running your tests, writing your tests, and there are tools built in. So there's reporting in Jasmine that'll show that kind of stuff. I don't know that I'm going to show a lot of that with our code here, but realize that you get those reports, and any project you come on board, unless you're starting out greenfield, it will have, and by greenfield I mean new project. It will have the coverage already built in. Somebody just has to show you how to run the coverage, okay, and how to see it. And then the other important concept here is cyclomatic complexity. So when I talk about branch coverage, cyclomatic complexity comes into play. And what that means, you can go look up the definition, but here's my definition. My definition is when I talk about cyclomatic, when I talk about that complexity, what I'm talking about is how complex is your individual function. And that stacks. So if that function has complexity, then the class that it's in has complexity, then the application has complexity. So, one of the ones you don't want is a lot of high-level function level complexity. And by that, we talk about branches through. So if you have an if, an else, another else, if you have a case statement with like 20 ways through it, if you have a ternary, any of those kind of things, those each provide branches through. Ways to get through your possible methods from the top to the bottom of your code. Okay, cyclomatic complexity can also be impacted by asynchronous activity, which can be difficult as well. So we need to manage that a little bit. You want as little complexity on your functions, and what you'll see on mine usually is about 5 or 6 lines of code. If it goes beyond that, I need to rethink it sometimes. Okay, you'll see an example in here where I have a little bit larger when we get to the code. But there's a specific reason for that in that case, and you'll see there isn't a great way around it. Okay. So when we talk a unit test, okay, arrange, act, assert are the three key rules, keywords to keep in mind. Arrange, or these steps you set up for your unit test. Okay, this is the setup. This is the configuration. What variables need you to declare? What do you need to spy on? What do you need to do to make things work? Okay. We will talk. I don't know that I talk about spies and stubs, but we'll talk about them in the code a little bit. But basically, spy says, hey, I got a function on my class, and I'm going to be calling it within this function. I'm going to spy on it. I can change the result, so I can do an and return value. I can stub it, which means it just doesn't run it, and I can check that it ran. And when I check that it ran, I can see what was passed to it. Okay, so I can do all kinds of things to manipulate a little bit and isolate things down when I do my testing. Okay, act is the next step. So we have the arrange, we have act. So you have to do something. There's some function on your class or whatever that you're running. Okay, this is what you're testing. Okay, that's the target function, target behavior. Okay, and assert, we're going to assert outcomes. Now, in general rule of thumb, is your assertions, you have one assert per unit test. I break that one all the time. All these rules that we might talk about here can be broken. Okay, try and have a good reason why if you're going to break it. Okay, so lots of talk. Let's take a look at code. So I'm going to get rid of this because we're not coming back to the slide deck. We're going to get to the end and I'll say goodbye and all that without having the deck up. Okay. Okay, so let's look at some code. Okay, I've got a basic user structure here. And as you can see, I've got a long array of users, just one, me. I'm going to keep it simple. Okay. Got a list of types down here that I'm utilizing in this user model. And when I talked about complexity and branches through, right here, I have 3 branches through. Okay, whether they're a developer, in management, or unknown. And I can see right here I've also got another error because this is a class constructor. And so this should be this.types and this.types. And here we can actually, yep, we're good there. Oh, sorry. So looking at this, I can see that there's a clearer pattern. Okay, and I left this in to kind of talk through it a little bit. Okay, what we're doing here is we're checking to see if an array includes. If we took this and we said solutions developer is a developer type, and now we can copy this line without the period, make it a comma. There we go. And I'll say it again and again and again through this that I will make mistakes. I'm going to leave the mistakes into the talk unless they get to be too bad. Okay, I did have to stop at one point, and this is the second round on that because something wasn't working quite right. And the Scrum Master is in management. I left this last one because we do have an undefined. And we can actually get rid of the quotes on this. We only need the quotes on the other ones because the JSON needed the quotes around because of the spaces. Undefined doesn't have a space. So, so undefined is unknown. There we go. What does this mean? By setting it up this way. What this means is rather than this switch and return, we can now change userModel into return this dot types subuser dot title, or okay, so if user.title doesn't exist on the list, we get undefined. So the or allows us to put in our default. Okay, oh, and let's make that instead of undefined, we'll make it types dot default. This dot types dot default. Okay. which means, guess what? We get rid of all of this, and instead of having 3 branches through, which originally was 4 branches through when I used equals to check each type value, we're now down to 2 branches through. And that doesn't matter how long this gets. 2 branches through. Much easier to test, okay? So we've made that adjustment. Let's take a look at our tests here, and real quick, I don't know why that wasn't clear. Oh, that was weird. Let's run the test. The test run. What does that mean? Well, it could mean we have false tests and things are broken and something weird is going on, but let's take a look, okay? So the test has a describe. We're importing the API service. We're importing this service, okay? We have a describe. And describes can be nested, so you can have another one inside, and the describe essentially is one big function. Big function. Oh, I'm grabbing on the before each. There we go. The describe. There we go. Okay. So you can nest another one inside it, another one inside, another inside it. Why do people do that? Okay, I tend to like mine flat. I tend to like mine flat because of when you have it nested, it indicates to me that there's some complexity in the project. Now, there are reasons to break every rule, but if you had an API service and your API service was 3,000 lines long because you've got API calls and returns for your entire application, your application is massive, you need to break these up with nested describes so you can see where you are and what you're testing. My point would be, wouldn't it be better to break that up and maybe have an abstract API service that covers a lot of the reduplicated code, that lets you set up services that are cleaner and shorter and easier to read and manage about. Okay, so we have a before each, and the functionality, I do believe Jest and Jasmine both have the describe, and they both have a before each, and they have an after each. And they have a before all and after all, and those allow you for setup and configuration and teardown. Okay. You can have multiple before eaches at one time, and if you notice a before each, after each, and all of these, they just send it a function just like we did with the describe. Okay. Inside this before each, we're setting up some data. We're setting up our service, our new API service. So here we've got a let that's in at that scope level that we're now assigning a new API service every time we run a test. So we know this is the default data every time we run a test. Problem with doing this way, and I have another talk. It's on what not to do. And this is one of those you probably shouldn't do, but I had to pass something in on this one, so I kept it simple. But the problem there becomes if I've got like 300 or 400 lines of code and I'm down at the bottom, how do I know what was passed in? It's just a readability thing, okay? The actual test is an it. I believe that's the language in Jest. Might not be, but it's close. And here we're expecting, so it expects getUsers to return an empty array. I wrap getUsers, which is the function I'm testing, inside of quotes, and I do that so it makes it easier to search for. Okay. In here we're setting users to undefined, so we're firing the setUsers, sets the users variable to undefined, and then it executes. Okay, so that's our setup, right? Assert act stuff. Okay, so we're setting it up. We're executing getUsers. That's the getUsers, which is down here. And because this is undefined, this .users is undefined. It returns an empty array. That's why that one test is passing. Perfect. Okay. Now I tend to put my tests in the order of the functions that I'm testing. Okay. So in this case, as we look at this, we have setUser setTypes. Okay. Nothing too complicated there, but we don't have any tests against those. I want them in order. Okay, so I'm going to come down here and we're going to write some tests. So it expects setUsers to set the service users to the incoming array. And it is kind of descriptive of what's going on. These the good, hopefully good descriptions become your documentation of sorts. Okay, so we need to set up. So what do we need? We need a set of user data. So const user data goes an array. So we're going to make an array. Does this array have to match this array? No. If I were using TypeScript, yes. Okay, for testing purposes, we can cheat a little bit. So my users are going to be name, Bob. I'll put a comma at the end of the line. I'm going to copy this a couple times. I don't need a lot to test it. And my wife Jen and my son Patrick often find their way into my unit tests. So this is my setup. I set up a variable. Okay, this is not a complex function. I don't have to do a whole lot. Okay, I don't have to mock or stub. Okay, we might get to mocking and stubbing later on. In fact, we probably will. Okay, but for now, we got this. So we're setting up the user data. I like to have a blank line in between my setup and my act on assert down below. So here, I'm not returning anything from the setUsers function, so we're just going to fire service setUsers, and we pass in user data. So our expectation should be, now initially it was set to this user data up here, okay, when we initialized and it ran through the constructor. There we go. Okay. So expect that service dot users to equal. Now you saw the 2b. 2b works. I'm leery of it. I like to be explicit in my code, and 2b handles truthy and falsy. I would rather do something equivalent to a triple equals. Okay, so to equal works for me, and it's going to equal user data, hopefully. Right? Save our file. Let's run our test. I got 2 passing tests. There's the camera. All right. 2 passing tests. So setUsers is done. So I'm going to minimize that down. Now, I didn't minimize getUsers because I've only tested 1 branch through. I've tested the first if branch. I haven't tested the return on it yet. Okay. So what happens next? Okay. Well, next is setTypes, and setTypes is almost identical to setUsers. So let's come down here. Let's copy. And this is setTypes. And setTypes doesn't have to be much of anything other than an object, but let's grab our, oh, we didn't modify that one to match our new one. So let's grab that and we'll fix both at the same time. And I'll show you how we'll make sure the test doesn't false positive on us. All right, so we got here, we want to copy that data here, but we need to make that an object, right? There we go. So how do we make sure this doesn't use the one up top? Well, I'm going to change these to ABC. Okay, anything different will work. And I'm not worried about the default unknown. So we're going to set the types. I'm going to pass it. This is type data. Copy. Type data. Expect service.types to equal type data. Might work. Like I said, I do get errors at times, but we did get 3 passing tests. All right, cool. All right, so we got setUser, setTypes completely covered. There's only one way through those sets of code. userModel has 2 ways through. So we should have, in my mind, logically, if I see 2 ways through, I want 2 tests. Okay, so we'll do an it expects userModel. Actually, I'm going to back up this code for a second. I want to check something. Okay, so we're changing the user. We're adding user.type. Okay, so we don't have to. Oh, we do want to return user. I wrote this wrong. Return user. And this is where you find mistakes. We're returning user. We passed in a user. Okay, so then here, user.type equals one of those 2 and return user. Okay, so modified user, we're adding a type, which if you look at my user, there's no type. If you look at the user in the test, there's no type. Okay, this is where you find mistakes when you're working through tests. Okay. Oh, there we go. All right, so let's rerun our tests since we found a small bug as we get ready to write that, or got ready to run that, write the test. Okay, so our 3 are still passing. We need to test userModel that it's adding type to it, which means we can probably reuse this user data, right? But how do we reuse the user data? Okay, so it expects userModel to do something. Well, we want to test the left side to assign a proper type, right? This is what we're gonna do. We need to use that data. Okay, doesn't have a type on it yet, but we need to also do a service set type. I don't want to count on anything else. Oh, we don't want to set type, we want to set users to user data. And now that I think about this, we're just passing a user and get a checked, so we don't need any of this. What we need is a const user that's going to be just a single user, right? But that user is going to have something specific on it, which is going to be, it has to have the title. And it has to have one of our titles that we passed in up here. Okay. So we've got a user. So we have to pass that user. And in this case, we're getting returned a value. Okay, so return user. So we're going to set up a const result, and I almost always use result this way. Service dot user model, and in service user model, we're passing user. We expect result to equal. Well, what do we expect it to equal? Oh, we got 2 equals in the wrong place. Well, this is where I sometimes will put in something like this. I'll do const expected, and it's this, right? Oop, no space. If we put space in, that throws off that. But we need it. It should include a type, and the type will be developer. So I've now created an object that should match what we expect. So expect result to equal expected. Okay. Might work. I can't guarantee anything I'm going to say here is going to work first time. Thankfully it did before. Okay, I'm going to clear for the moment so we get some stuff off our screen. So we've tested this path through. We need to test the default. Okay. Shouldn't be too much different. So let's come in here and to handle an unknown title. Oh, what's an unknown title? Well, let's do this. Unknown title. So it still should have that on there, but the type now would be unknown. Right? So really all I have to do is change my setup. My test expectation should be exactly the same. Okay, the run and the expect. So let's run it. Hey, 5. We've got 5 working unit tests. Awesome. So user model is now covered. I've covered both branches this side. All it's doing is returning here. Okay. getUsers. We have 2 paths through, but we're right down to getUser here. Okay. getUsers. getUser. All right. So we've tested undefined. We need to test what happens if it's not undefined. Okay. And this is not tricky. I'm just going to copy this so I get the language. Return the processed data. All right, well, how do we know it's processed data? Well, let's take this. Okay, because it's going to return a user. So we're going to steal the user data for right now. Because I want to validate, I want to know what data I'm giving it. Okay. So we're going to set the user to user data. But when we call getUsers, it's going to take users, it's going to loop through all of them and pass it through userModel. Looking at solutions developer here, I should get a, oh, sorry, I don't need to scroll up there. I should get that he's a developer as a type added onto it. So I need to have an expected on this one because it is going to be a little different, right? And yes, you could put in more complicated versions of the data and that kind of stuff. I'm keeping it simple. And we can keep it even more simple because really I could just do title on the user data and expect this to be title and type. So what have we done? We've set the user data to a fixed known set of data. We're expecting it to come back once we change it. So we have to fire getUsers. We're already firing getUsers. Notice we're not passing anything in. We set it up here. So it should process it through the map, update the data, and return it. Now our result is no longer be an empty array. It should be expected, which in this case is solutions developer with type developer, right? So let's see what happens. Oh, passing. Yay, 6 passing. We're down to 2 functions. I tried to put a lot in here so you can get to see this over and over again. Okay, there are things you can do to handle async and that kind of stuff, but I don't want to go on here for like hours and hours and hours and hours and hours. I already have quite a bit in here. I don't want it to be a thorough end-to-end. I just want to give you a rough idea of where you could start, okay? So, getUser. How do we test the getUser function? Get expects getUser to return null if user is undefined. What does that mean? Well, we're doing a find in there, right, on users, and we're looking for user ID matches user ID. So if I pass it a user ID that's not in my list, so guess what? We need our user data again, because I want to make sure my test things are set up the exact same way they should be. So we're going to say service.setData. This is part of my setup. Set users to user data. User data. Okay. Now we have to pass an ID. So I'm going to say const. Really, we'll say const user ID. Now I want it to be different. It'll be different enough to not have it. Now we need to act, right? So we'll say const result equals service get user pass it the user ID. Expect result. Now here's a fun one. To be, this is one case where I'll allow it to be null. Jest has something similar. All right, so in this case, we should have half of our branching through, right? So it's come through, it's gotten a user, it didn't have a user, so it comes back as user undefined and it returns null. The other option would be it found it and it returns it after passing it through userModel. We passed. Okay. Second branch. Shouldn't be too difficult to write. We'll need an expected in here, but that's easy enough. To return processed user. So we're going to leave the same user data. I'm okay with that. We'll make the user ID 1, but our expected and now this should send back a single user. Okay, it's finding it in this array. So we need this part, not the whole thing. Okay, and it's not real picky on order on objects, so we're going to say type developer. Oops, comma, there we go. Semicolon there. We pass it a user ID. We're going to expect the result to equal expected. Now, I often say you don't really want big, long setups, but this is not bad. I mean, it's not horrible. I can read the whole thing in one place. Can I strip this down? Sure. I can take the name, the user ID, because all I really care about is the title, like we did before. But it's okay to leave that in as well. Okay. And let's rerun our tests to make sure they're still working. Should have 8 working tests. Yay. Okay. Now we have set username. Okay, this one's a little trickier. And what I want to do in here is I want to intentionally inject some failure so you can see what it looks like and how to track it down. Okay, so let's write one here. So it expects, there we go, set username. Now, what does it return here? Okay, we have to look at our function. So we get a user based off of user ID. Now we have the possibility that user is undefined, which means we didn't have that user ID in our system. If it didn't have it in the system, then users should not be changed. If it did have it in the system, it should update the name. Okay, well, we got this part, and we got a user ID. So let's actually grab this up here. Okay, because it returns expects set username to do nothing if user does not exist. Okay. So we're going to put that code in that we copied. So we've now set it the user data. We've now told it we're going to work on user ID 2. We need a name. We're going to set it to. Easy enough. And we need to act, right? So service. Oops, we're getting return values. So const result equals service. Set username. User ID. Name. Expect result. Here's an interesting one. To equal user data. It shouldn't have changed anything, right? So I should be able to check it. It should be, user data should be unchanged. Okay, so let's run our test and make sure it's unchanged. It is. Okay, now let's put our fault in this next one. Okay, so that's the last one we're gonna write, so we better put it in soon, right? All right, so I've set it up. I'm gonna set it to 1. I'm gonna leave it at new name. Okay, so it is gonna change it, because it's finding this user. It's going to change the name. But because we're looking for those to match, we might get a failure. Now, if we don't get a failure, then there's a problem in our set, and we'll fix that. Okay? We didn't get a failure. Now, there's a problem here then, because what happened is the reference to user data is set to our data. So let's come back up to our set types and users. I want to make a change here. I want to make sure this is a complete duplicate of the original data, that we are not using a reference. So what the ... does is it allows us to essentially expand that data in place, creating a copy. Okay, those two changes should still work on all of our tests, but this last one. Okay, data is not iterable. Well, that's an interesting problem. Data is not iterable. That isn't the failure I expected. Okay, so let's see what we've got here. Okay, getUsers. It failed on getUsers. It didn't fail on the set username. All right, so let's see. It failed on getUsers to return an empty array if data is undefined. So it's saying data is not iterable on getUsers. Return an empty array. So we set the users to undefined. Okay, so the problem here is we used setUsers. It builds an array, and undefined got stuck into the array. So to do this, we need to work directly against users to make this one correctly pass. All right. So basically what happened there is I can't pass it through setUsers because we are going to get an array. It'll be an array with an undefined inside the array. Okay, I wanted users to be undefined at some point in time so that we know we get that empty back. Problem is we still have a passing test here, set username. So if I had set an exit, it'll tell this pass not to run. Okay, I'm going to show you this real quick. There's a reason. Okay, temporarily didn't run that test. And they run out of order. So if I run this again, it's not in the third position, okay? We want them to run out of order because if your tests are dependent on each other, this will cause them to fail over time, okay? You don't want tests to be dependent on each other. Now, the problem is I'm passing in user data. It should be setting the users. I should have a new object. So something is going wrong. Theoretically, something's going wrong down here, causing it to fail. Now, what I want to do in showing you that was the other option is F. So X turns it off. F turns it on. Somebody can look up why. I just know they work. Okay. So let's run the F and see that the one test works. Okay. When it shouldn't. This is a false positive. So it should change the user's username. So let's see if it's actually getting the user, because there might be a problem with like it's finding it on an index or something like that. And maybe the user coming out is not properly put back in or something like that. So let's console log user right here and see what's going on. Okay, because this should have failed. I want it to fail. Okay, so it got the right user, and user's not undefined, so it should change the name. So let's check it here. Now we also know one other thing, since we set our data up. This.users, we know that the one we're looking for is in the first index location, right? This is a test we know should fail. What's happening? Okay, so the first console is the first object. Second console is the object with the new name changed. Look at that. That is the user's sub-0 that has the new name. So if the result equals the user data, then something's wrong here because user data should not have changed. Right? So here, let's console log and rerun. So at the very end, it changed the original object. Okay, so what I would do to correctly make this pass, okay, is have an expected, okay, and you can take that original array data, because I want to define exactly in this test what we're doing, and we'll change this to name. And since we're on a modifying name, let's slim it down. Remember I told you up above, we don't always have to, get something down that far. We need the user ID, right? And then here we could do the same. And our expected. We want to change both of these so they have the expected, okay? So in here we should expect, let's leave that expected that way and make sure that fails, okay? Why is that going to fail? Well, the expected should match the original value, Okay, oh, my console logs are still in there. So this one's passing. Let's include this one. We got a lot of console logs. There we go, got an error. All right, so let's get rid. First of all, let's get rid of our console logs because the error will be easier to see. And we had one in there, right? We're expected. It's too low. There we go. So let's clear this and rerun. So what we see is we have a failure. The name Bob Fornell should equal new name. Okay, the name Bob Fornell. In the result, what came back was Bob Fornell. The array with Bob Fornell in it, right? What it expected was new name. This failed because it should do nothing. This should stay Bob Fornell. Okay, passing. All right, let's take our F's off. Test our entire suite. There we go. 10 tests against this functionality. I didn't do anything fancy with asyncs or anything like that. Although we could have. Okay. Not hard to do. We didn't do any spies or stubs. I didn't really want to show you that. I wanted you to see the basics of the functionality that we had. Okay, so we're looking at getUser. If I come in here, I don't want to look at the setUsernames. I'll look at getUser functions. These are the getUser tests where I set things up and I passed things in and I checked what came out at the end or what changed within our service, within our code. Okay, these at its core are reasonably good tests. Now, style can be different. Do you want to have the arrange act assert separate? You can't. I tend to like the two together there. That's my preference. Okay, layout, no big deal. Do we want to streamline these down to have just the data we need to pass the test? Maybe, but if you're using TypeScript, you may not have that choice. Okay. You know, the spying, stubbing, mocking, and that kind of stuff. Maybe I go into a deeper dive because this is a talk on the basic unit test, not the advanced unit test. Okay. So as I said early on in the talk, I said early on in the talk that the GitHub repo will be available. There was an article in there I referenced on how difficult it is to track down bugs and fix bugs once they reach production and that kind of stuff. I'll put the link in there as well. I hope this was of value to you, and good luck out there.